All right, so we're going to look at Unit 10, exponentials, logarithms, and E. On this review, we're not going to use a calculator unless it's stated that we can use a calculator. Okay, so starting with number 1, if e to the 8 times e to the 11th times e to the negative 7th equals e to the x, what's the value of x? So we're just multiplying these e's together, so we pretend like they're x's. We treat them just like it's, treat them just like they're x's. So think of it, instead of e to the 8, e to the x, or x to the 8, which means you're going to be adding your exponents. That's going to give me e to the 12th is what e to the x equals. So that means x must be 12. Okay. Number 2, select the best answer that describes the domain and range of the function f of x equals e to the x minus 3. So let's think about what e looks like when we graph it. Let me slide over just a little bit. When we graph e to the x, it's an exponential function where e is like 2 point something something. It's going to go through 0, 1, the parent function, and it's going to be exponential growth. So it's going to look something like that. That's the parent function. When I subtract 3 up here with the x, what that's going to do is it's going to move me to the which direction? To the right 3. Okay, so right now I'm here at 0. I'm going to move over 1, 2, 3. I'm going to be here. And so my new graph is going to look something like this. So what's my domain? What x values am I allowed to use? Yeah, I can go all the way to the left, and this continues to go out all the way to the right. So infinity to infinity. So that means it can't be any of those. So we've already said no, not B, not C, not E. And then what's my range? How low and how high? I go from what to what? 0 to infinity, right? Because I'm never going to go below this horizontal asymptote. So 0 to infinity. So the one that has the 2 check marks on it is A. Questions on 2? All right, let's go look at 3. 3 is another transformation one. This one's a little bit more complicated. When we look at this one, if I look at this graph, when I look at this 2 minus x, I really need to rewrite that so that it is e, oops, I wanted to change colors, so that the x comes first. So I'm going to rewrite this as e to the negative x plus 2 plus 1. But then that negative x, we need to factor that out of this whole little section. So I'm going to rewrite that as e to the negative x minus 2 plus 1 on the outside. Okay? So then if I think about what my original graph looks like, my original, bless you, my original graph goes right through here, and we just drew it on the last one. It does something like that, my parent function. And then when I have this negative right here, that negative is going to reflect it over the y-axis because it's not a negative out in front, okay? So it's going to reflect it over the y-axis. So that's going to turn us now so we look like this, okay? And then this minus 2 is going to move us where? Inside these parentheses. Right 2. So that's going to take this point here and it's going to move it over 2. So now we're going to be like here. And then the plus 1 on the outside does what? This plus 1 on the outside. Up 1. So this dot right here is really going to go up right here. So we should look like that blue graph that goes through 2, 1. So we should look like the blue graph that goes through 2, 1. There's only one that's even facing that direction. That doesn't go through 2, 1. I must have counted wrong somewhere. Oh, no, 2, 2, right? 1, 2, 2, 2. I looked at my y-axis wrong. 1, 2. So it is going to be this second graph right here. That's even the only one that's facing the right direction. Questions on 3? Okay. Let's go look at 4. Oops, cancel. All right, the expression 2 log base 2 of 6 minus log base 2 of 18 can be rewritten and simplified as log base 2 m over n, which is going to be log base 2 of p, which equals x. So the first thing I want to do before I can combine these two together, I need to take care of this 2 out in front. What happens with this 2 in front? I can't divide because I'm not equal to anything. What happens with that 2 out in front? It becomes a what? An exponent, right? So that's really going to become 6 squared. So that is really log base 2 of 36 minus log base 2 of 18. So then when we're subtracting logs that have the same base, that's when we can take the two numbers and divide them. So it'll be log base 2 of 36, the first log, over the second log, 18. What is 36 divided by 18? 2. So log base 2 of 2. And it says that that's just going to equal x, because remember, if the base and the of are the same value, then your answer is just the exponent. If I don't have an exponent on it, what is the invisible exponent on it? 1. So what does this whole expression equal? 1. Okay, so the value of m is 36. This is m. 18 is my n, the denominator. P, log base 2 of a single value, log base 2 of 2. And then x equals 1. Questions on 4? Okay, let's go look at 5. All right, if log base x of 1 over 25 equals negative 2, what is the value of x? So what we need to remember, and somebody might want to make a poster about it if you want, put it on the wall, is when we see this log base x of 1 over 25 equals negative 2, remember the base to the answer equals the of. The base to the answer equals the of. Okay, so when I look at this log, yes, when I look at this log, what is the base? X. What's the answer? What does this equal? Equals negative 2. Equals the of. What's the of here? 1 over 25, right? Log base x, base of 125. So my of is 1 over 25. Equals negative 2. That's my answer. That's the exponent. Okay? If I asked you to rewrite x to the negative 2 as an exponent that's not negative, how would you rewrite that? No? You have the right idea about moving to a denominator, but we don't change just the exponent. 1 over x to the second, right? 1 over x squared is the same thing as x to the negative 2. Equals 1 over 25. So then we can deduce by looking at this, and that means this denominator must be equal to this denominator. Or if you want to do it mathematically, you can always say, oh, that means x squared times 1, cross multiply, right, equals 25 times 1. So x squared times 1 is just x squared. equals 25 times 1 is 25. How do I unsquare? Square root. So x equals 5. And normally we would say positive and negative, but when we're dealing with logs, we know we have a horizontal asymptote. We don't have any negative bases, so it can only be the positive 5 because we have that vertical asymptote at y equals 0. Or sorry, x equals 0. Okay, questions on 5. Okay, let's go to 6. Number 6, solve the following equation for x. So I'm going to do the same thing. The base to the answer equals the of. The base, what's my base here? 4. To the answer, what's the answer? 1 equals the of, what's the of? X squared minus 3x. So in order to solve this, because I have an x squared and a 3x, I'm going to have to set this equal to 0. So this is really just 4, because 4 to the what first is just 4, equals x squared minus 3x. I need it to be set equal to 0 so I can factor it. So when I do that, I get 0 equals x squared minus 3x minus 4, and then I'm going to factor that. It's an easy one to factor because there's not a leading coefficient on x squared. So when I factor it, I just need to know what multiplies to a negative 4 and adds to a negative 3. Multiplies to negative 4 and adds to negative 3. 4 and 1. Which one's negative if I want to get a negative 3? The 4. So that equals 0. I just wrote my equal 0 on the other side. That's okay. Which means one of these two equals 0. So what are my two values for x? X equals 4 and negative 1. So x equals 4 and x equals negative 1. In this case, it's okay for x to be negative because it's not part of the base. Our base can't be negative. Okay? Questions on 6. Okay? All right, next. I don't know why it says number 1. Pretend it doesn't. The numbering got all messed up when I move things around. Okay, the function h of x equals log x plus a plus b is graphed below. The parent function has been graphed as a dashed line for context. What's the value of a? What's the value of b? So if I look at my parent function and I compare this point right here to this point right here, my a value is moving left and right. Which direction did I move to get from the dotted line to the solid line? Left or right? Left, how much? Left 1, right? I have to move back 1 to get there. So left 1, which means what am I going to put here for a? Plus 1, so positive 1. And then my b value, how far up am I going? 4. So I'm going up 4, which means that's going to be plus 4. Questions on this number 1? Okay. Seven. The equation of the graph below can be written as f of x equals a e to the x plus b plus c. So it's an e function, which means normally it goes through right here, and it looks something like this. Bless you. I can see it's been flipped over upside down, so what does that mean has to be multiplied if I've been flipped over upside down across the x-axis? Yeah, so this a value has to be a negative 1. Okay, and what that's going to do then, will somebody grab the door? That's going to flip us upside down, and that's going to make me then look like this when it flips me upside down. Okay, but then I've moved. Which direction have I moved? from here, I've moved to the right. Let's see, I'm going right here. 1, 2, 3, 4. So up here, x plus b, what's going to be my b value if I'm moving to the right 4? Minus 4. And then I'm moving down how many? 2. So what's going to be my c value? Negative 2. Good. Questions on 7. Okay.
Wait.
Yes.
Is the C 3 or 2?
So I'm right here, and I'm moving down 1, 2 boxes.
Oh,
Yeah.
Where did we get the original word?
This original gray one?
Yeah.
Because it's an, I see the e there, so I know the parent function, the parent, is going to be y equals e to the x, which I know looks like this. I know it goes through right here at 1, 0, and it's an exponential function. This one's my parent. Okay, and then this one here, the second one I drew is the y to the negative e to the x. And then from there we moved it right and down. Okay. All right, number 8, the inverse of the following function is in this format. So remember, for the inverse, we need to take this function, instead of saying f of x, I'm going to say y, e to the x minus 2 plus 4. And we switch our x and our y, and then we solve it for y. So if I switch my x and my y, and I want to solve this for y. So the first thing I'm going to do is I need to get this e to the y minus 2 all by itself. So I need to get rid of this plus 4. What do? Subtract 4. I know eventually it's going to turn into a log. But first I'm going to deal with just simplifying the exponent, the exponential part. So I'm going to have then x minus 4 equals e to the y minus 2. Okay, so now it's in log form, or it's in exponential form, where I just have an exponent on one side and I have an answer on the other side. Remember, we say that the base to the answer equals the of. Notice I wrote it backwards, because I wrote the base to the answer on the side that has the exponent. Does that make sense? I wrote the base to the answer on the side that has the exponent. So what is my base? What's my base? E. So this is going to be log base e, which we could write as ln, but they want us to write it this way, so I'm going to leave it this way. Of, what's the of? Yeah, the of is x minus 4. And what's the answer? Y minus 2. So we're still not set equal to y. What do I still need to do to set this equal to y? Add 2. So that's going to give me log base e of x minus 4 plus 2 equals y. And since we switched our x and y, that means this whole equation is equal to my inverse of x, because we switched to the x and the y to get here. Log base e of x minus 4 plus 2. So what is my value of A? E. What is my value of B? X minus 4. And what is my value of C? 2. Questions on 8. So remember, when you see inverse, it means we're going to switch our x's and our y's. Any other questions on 8? Okay, let's look at 9. Which equation has the domain of -6 to 6? And all of them are logs. If we think about a log, the parent function for a log, the parent function for a log is going to go through 0, 1, or sorry, 1, 0, and it's going to look something like this. That's going to be my parent function, just log of x. Now, if I want my domain, my x values, to be able to include a negative, that means what I'm going to have to do is I am going to have to flip this around so that it's going to go like this. So that way, it's going to go over the, actually, it's not going to go quite like that. Well, let me just, oops, undo. Oh, why did I slide? My screen is like dancing now. Went far. Oops, this time I went too far. Okay, so when I reflect it, it's actually going to, I don't know if it'll let me just select just this part. Nope, it's going to make me do the whole thing. When I reflect it to turn it around that way, it's actually going to flip it across this axis, so that would move it here. What do I do in my equation to flip it over like this, to flip it over the y-axis? If it was to flip it over the x-axis, I'd put a negative out in front. But I'm not putting a negative out in front. Where am I putting the negative if I want to flip over the y-axis? In front of the x. So this would be log of negative x. That's what would flip it across, so it's going the other way. And so now at least we're going to negative infinity. But right now, our graph is not going to just negative, or it's not going from negative infinity to 6. It's going from negative infinity to 0 is where my y-intercept is, right? So, or my vertical asymptote is at 0. So that means if I want to go all the way to 6, I need to move that horizontal asymptote over 6 places. So I actually need to take this graph and move it over 6 places so that it looks like this. So if I take this orange graph and I move it to the right 6 units, then that's going to be log of negative. What do I do to the x to move it to the right? To move to the right, I take away 6. Notice what I did. I didn't include that negative in that. So I have something similar to this, but notice it has the wrong sign here. I don't have anything that looks just like this, but has the correct sign. So that means I need to distribute the negative in, which is going to give me log of negative x plus 6. I don't see negative x plus 6, but this could be rewritten as log of positive 6 minus x. What's my correct answer? A. I don't know why that one's highlighted. There we go. Questions on 9. So you do need to be familiar with your parent functions, what they look like, so that you can transform them. Okay. Write the following number in standard form. Right now it's not in scientific or standard notation, but it wants us to go to standard form. Standard form is the one that's not multiplied by anything, which means I need to take my 10 to the negative 2, and I need to make it a 10 to the 0 so that it's just a 1. Because if you multiply by 1, you don't have to write that down, right? So my negative 2 is actually getting bigger, which means this number is going to get smaller, right? By how many places? 2. So it's going to go 1, 2, and we're going to end up with 8.026 times 10 to the 0, but that's just times 1. So 8.026 is my standard form. Questions on 11? Okay. So this time I want to take, on number 11, I want to take this number and I want to put it in scientific notation. So this time I do want the times 10 to the whatever exponent. So when I do this one, I'm going to have 5.046. You keep going until you run out of numbers that aren't 0, right? I do need to put that one in there because it's sandwiched in between other significant digits. Times 10 to the, I made this big gigantic number smaller, so this number is going to get bigger. Right now there weren't any 10s, so I'm going to add to 0. How many places? 7. Questions on 11? Okay, let's go look at 12. Number 12 says I get to use a calculator. It's going to take it a while to open up, so I'm going to click on that now so it gets started. Use the amortization function. If I remember right, last year they did give you that formula, but somebody might want to put it on a poster just in case for some weird reason they don't this year. So remember, what I like to do is I like to say, okay, A sub 0, R, N, T, and that way I can organize my information. An investment has a 6% annual interest rate. Where does that go? R. And when we put it in the formula, we're going to put it as point, oops, my computer's thinking. Give it a moment. It could be because the calculator's opening. Okay, we are back and good to go. So 6%, we're going to write that as 0.06. And it's compounded monthly. Where does that go? Where does it go? The number of times it's compounded per year? The number of times it's compounded, N. And monthly means how many times per year? 12. How many years will it take to triple in value? Now, when we did these in the worksheet, it gave us all but one number, and here it looks like it hasn't given us, it's missing 3 numbers. But I know if I wanted to triple in value, if I start with $1, how much am I going to end with? If I'm tripling in value, if I put in $1, I want to end up with $3. So that's what I'm going to do. I'm going to start with 1 because I like little numbers. I'm going to start with $1 so I can end up with $3. And how long, this is my variable, T, how long is it going to take me to turn that $1 into $3? So now we're just going to fill into this table, or in this equation. So I want to end up with $3 when I start with $1. 1 plus, I'm using a rate of 0.06 over, N is 12, to the N times T, so 12 times T power. Okay. Normally, the first thing we would do is we would divide by 1, right? The number that's out in front. But in this case, you don't really have to do that because it's 1, right? So it's not really like it's changing anything. We're just multiplying by 1. But you can still do it, and you can see that we would have 3 equals 1 plus 0.06 over 12 to the 12 times t power. Bless you. When you have an exponent that has a variable in it, you're going to have to turn it into a log. When you have an exponent that has a variable in it, you're going to want to turn it into a log. I'm going to say that one more time. When you have a variable that has an exponent in it, you're going to want to turn it into a log. Okay? And you can use whatever method you want to do. We can do the base to the answer equals the of. Or we could take a strategic log of each side, whichever one you want to do. Do you want to use the base to the answer equals the of, or do you want to try to take a strategic log? Base, okay. So we're going to do, this side is my exponent, right? That has the 12 to the t. So I'm going to write, just so I remember, it's the base to the answer equals the of. Okay, so I'm going to write it as a log over here. So my log base, what's my base? Yeah, it's an ugly base, but that's okay because we have a calculator. Base 1 plus 0.06 over 12. What's the of? 3. Equals the answer. What's the answer? 12 times t. If I'm trying to solve this for t, how do I get rid of that 12? Divide by 12. So on my right-hand side, my answer is just t. All of this has no variables in it. I can put this in the calculator. So in my calculator, if you have not practiced typing anything in the calculator, you should probably do that sometime between now and Friday, because the calculator is for part 2, which means I guarantee they'll have these kind of questions on part 2. Okay, so log, I have to hit control log. My base is 1 plus that fraction. I'm going to do control divide so it even looks like that fraction. 0.06 over 12. And then I'm going to arrow to my of. It's of 3. And then that whole thing is being divided by 12. And you'll see it'll fix it when it rewrites it so it looks just like it does on my paper. And so my answer is 18.3559. 18.3559. Oops, let me get orange. 18.3559 equals t. It says, how many years will it take to triple in value? Round your answer to the nearest tenth. So it's going to take me 18.4 years. That's a long time to turn $1 into $3. That probably wouldn't be how I'd do it. Yes?
Why did you put of on the other side of the equal sign if you put it as the exponent?
It's not an exponent, it's log. This is all a base. This is the of. That's not an exponent to this. It's log base of equals a number. That makes sense? Okay. And if you look at it in the calculator, you might be able to see it better. It's log. This is all the base of the 3. Okay? Yeah, it looks weird. It's a weird one to look at. All right, let's look at 13. The rate of decay for a particular type of radioactive particle is relatively constant and can be represented using this equation, which is kind of scary, but that's okay. Let's see. It says T is time, N is the mass of the sample, and T sub 1/2 is the half-life. So this T sub 1/2, don't let that scare you. It's just a variable, like the A sub 0. It doesn't mean you have to do something with that sub 1/2. It's just another variable that it takes the sample to decay. So if I think about what my variables are N sub 0, T, and the half-life T. Those are my variables. So when I read the half-life of carbon-14 is about 5,730 years. So they already gave me this one, 5,730 years. How many years would it take a 2,000 gram sample, so that means that's where I'm starting, to decay to only 300 grams? All I'm looking for is T. Now this is ugly, and so we have to be real careful with it, okay? N of T is going to be my N, so that's 300. Equals N sub 0 is 2,000. E to the, I should move all of this down. Hold on, let me see if it'll let me select. I want to select all of you. There we go. That way I have room for that gigantic exponent. Okay, so my exponent is this whole fraction thing is my exponent. Negative ln of 2 times t over the half-life, 5730. Before I can do the base to the answer equals the x equals the of, I have to get rid of that 2,000 in front of the e first. How do I get rid of the 2,000 in front of the e? Divide. It's just being multiplied. So that's going to be 3 over 20. We can use a calculator on this. So if we want to turn 3 over 20 into a decimal, we can. It turns into 0.15. Do we want to do that? Okay, so this is going to be 0.15 equals e to the negative ln of 2 times t over 5730. This whole thing is the exponent to that e. Okay? So remember, my base to the answer equals the of. Okay? So when I come over here to do that, my log, what's my base? E. So I could also do it as a natural log, right? When we rewrite it, we could write it as a natural log. Of the answer, what's the answer? Oh, sorry, what's the of? I lied. 0.15 equals the of, what's the answer? Yeah, that's my negative ln times 2, or of 2, times t over 5730. All right, so now I'm trying to solve this for t. Probably the easiest way to do it is think of this. Oops, I wanted a different color. Think of this side over 1. So I've got 2 equal fractions, and I can then cross multiply. So when I cross multiply, I'm going to rewrite this instead of log base e. I'm just going to call it log of n. So it's going to be this 5730 times, I'm going to call it the natural log because it's log base e, of 0.15 equals negative the natural log of 2 times t. How do I solve this for t? Yeah, divide by what's being multiplied to it. Divide by the negative natural log of 2. Divide by the negative natural log of 2 so that this cancels out. And on my right-hand side, I just have t. All right, let me grab a calculator. So it's going to be, I'm going to do control divide, so it's a fraction. In my numerator, 5730 times the natural log of 0.15 over negative natural log of 2. When I hit enter, I get 15682.8. 15682.8. Round your answers to the nearest tenth. It automatically did. So it's going to take 15,000, over almost 17,000 years, like 15.6 thousand years, in order for that sample to decay. That's why we do a lot of things when they say they carbon date things, because it takes carbon so long to decay. That's why they're using carbon dating for things, because carbon tends to last in things for a really long time. Okay? All right, so the next video that I will upload will start with number 14.